Titanoboa held the crown for 15 years. 13 meters, over 1,000 kilograms, pulled from a coal mine in Colombia and handed the title of the largest snake that ever lived. And if you know Titanoboa, you already know the story. You know the Cerrejón formation. You know the size estimates. You know what kind of world had to exist for something like that to be real. But while Titanoboa was being paraded across headlines and museum exhibits, there was a collection of bones sitting in a drawer at the Indian Institute of Technology in Roorkee. 27 vertebrae pulled from a lignite mine in western India back in 2005. They'd been catalogued, briefly examined, and shelved. The preliminary notes said crocodilian. Nobody looked twice. For 19 years, these bones gathered dust. Then in 2024, a postdoctoral fellow named Debajit Datta and his supervisor Sunil Bajpai decided to take another look. The vertebrae had come from the Penandro mine in the Kutch district of Gujarat, a gray shale unit within the Naredi Formation, dating to the Middle Eocene, roughly 47 million years ago. And the bones were massive. Individual vertebrae up to 11 centimeters wide, broad, cylindrical, thick-walled. When Datta ran the measurements against known snake taxa, the numbers didn't just suggest a large snake. They eclipsed every member of their entire family. 22 of the 27 vertebrae belonged to the trunk, still partially in articulation. This wasn't scattered fragments. This was one animal, and it was enormous. They named it Vasuki indicus, after Vasuki, the serpent king of Hindu mythology, coiled around the neck of Shiva. So how big was it? And this is where it gets frustrating, because the honest answer is, it depends on which equation you trust. There are two ways to estimate a snake's length from its vertebrae. One regression uses a bony projection on the back of each vertebra. The other uses one on the front. Same bones, different landmarks, 4 meters of difference in the result. The first method gives you 11 to 12 meters. The second gives you 14.5 to 15. At the lower end, Vasuki is one of the largest snakes ever found. At the upper end, it's 2 meters longer than Titanoboa. Bajpai himself told Reuters they cannot say whether Vasuki was more massive or slender. No complete skeleton exists. No skull has ever been found. The honest framing is potentially the longest snake on record at its upper estimate. Anything more definitive than that is overselling the evidence. But here's what the vertebrae do tell us. Those proportions, broad, cylindrical, heavy-walled, point to a thick, muscular body. Not a sleek swimmer, not a fast mover. The authors interpret Vasuki as a slow-moving terrestrial ambush predator, comparable to the largest living pythons, just scaled up to a size that shouldn't be real. An animal that sat, concealed, in a landscape that made that strategy lethal. 47 million years ago, Kutch wasn't the arid scrubland it is today. It was a coastal lowland at the edge of the shrinking Tethys Sea, choked with swamp forest and tidal marshes. The rocks Vasuki came from sit right at a hyperthermal event called ETM2, one of the sharp temperature spikes that punctuated an already hot greenhouse world. Average temperatures estimated around 28 degrees Celsius, and that's a mean, not a peak. The swamp was full of catfish, turtles, crocodilians, and at the coastline, some of the earliest whales. Andrewsiphius and Cuchacetus, small, semi-aquatic ancestors of modern cetaceans still figuring out life in the water. Vasuki didn't need to chase anything. It just needed to sit near the water and wait. 1,000 kilograms of muscle coiled in a swamp in a world hot enough to make it possible. Now, everything you just heard probably sounded familiar. Giant snake, swampy environment, ambush predator, extreme heat. You've heard this before. And on the surface, Vasuki looks like the same story as Titanoboa transplanted to a different continent 10 million years later. It's not. And the reason it's not changes how you think about the entire biggest snake question. Titanoboa was a boid, same family as modern anacondas. It had a flexible, kinetic skull designed for wide gape feeding, meaning it could unhinge its jaws and stretch them around prey far larger than its own head. That's the trick that makes anacondas what they are. Titanoboa took that system and scaled it to 13 meters. A giant, but a recognizable one. You could look at Titanoboa and see the anaconda in it. Vasuki belonged to the Madtsoiidae. No living members, no modern analog. Nothing alive today that carries their blueprint. And the difference that matters most is the skull. Modern boas and pythons have skulls that are essentially disassembled. The bones of the upper jaw are loosely connected to the brain case. The two halves of the lower jaw aren't fused at the chin, and the whole apparatus can flex outward to accommodate prey much wider than the snake's head. That's macrostomy, wide gape feeding. It's the defining innovation of advanced snakes. It's what most people picture when they think about how a snake eats. Madtsoiids never evolved it. Their skulls were low, broad, and rigid. The snout was locked to the frontal bone. The upper jaws had tight connections to the brain case. They retained a jugal, a bone every living snake has lost. When Scanlon and Lee described the Wanambi skull in 2000, they concluded that cranial kinesis was more limited than in any living snake. These were animals with the body of a giant constrictor and the feeding apparatus of something far more primitive. So if they couldn't open wide, how did they eat? Wilson and colleagues showed that Madtsoiids had some intraoral kinesis, the ability to walk prey backward through the mouth using alternating movements of the palate and jaw bones. Combined with sheer body size, this let them consume moderately large prey, but not the oversized meal a boa or python of the same length could handle. The gape was the bottleneck. A 15-meter Vasuki couldn't swallow anything a 4-meter king cobra couldn't, proportionally speaking. Same size class as Titanoboa. Fundamentally different animal. A giant built on an ancient chassis, one that predated the evolution of the very feature that defines how most snakes eat today. And that chassis was old, far older than you'd expect. The Madtsoiidae appear in the fossil record around 100 million years ago, late Cretaceous, when the southern continents were still recognizably Gondwana. They spread across Madagascar, South America, India, Africa, Australia. 14 genera, 23 species, the longest temporal range of any snake family ever recorded. And here's the problem with understanding them. Their phylogenetic position is still genuinely unresolved. Some analysis place them inside the crown group of living snakes. Others push them outside entirely, as stem snakes that split off before the modern radiation even began. The uncertainty exists because most Madtsoiids are known only from vertebrae. Only about 4 skulls have ever been found. You can't build a confident family tree from spinal columns alone. But what those vertebrae do tell us is a story about geography, and it starts with India being an island. In the late Cretaceous, India had rifted off Gondwana and was drifting north through the Tethys Sea as a massive tectonic raft, completely isolated, and it was carrying passengers. Madtsoiidae pesdurensis and Sanahe indicus both come from late Cretaceous Indian deposits, proof that Madtsoiids were already established on the subcontinent while it was still alone. Sanaja is worth stopping for. In 2010, Wilson and colleagues described a 3.5-meter Madtsoiid preserved coiled around a clutch of sauropod eggs at a nesting site in Gujarat. A titanosaur hatchling, 0.5 meter long, lay beside it. The whole scene frozen by a flash flood. A predation event captured in stone. Saneha means ancient gape in Sanskrit, a reference to its limited primitive jaw. It couldn't swallow the eggs. It was waiting for the hatchlings to emerge. One of the rarest things in paleontology, direct evidence of behavior, not just anatomy. But Sneha also demonstrates the constraint. Even at 3.5 meters with a hatchling right there, the jaw was the limit. The same bottleneck that defined Wanambi, that defined Vasuki, that defined every Madtsoiid for 100 million years. They never solved it. They never needed to, because they found other ways to be effective, but they never solved it. So India drifts north. Around 50 million years ago, it collides with Asia. The Tethys closes, and suddenly there are land routes. Data and Bajpai argue this is how the lineage reached North Africa, dispersing through southern Eurasia to produce Gigantophis garstini in late Eocene Egypt, around 40 million years ago. Gigantophis was the first Madtsoiid ever described, named by Charles Andrews in 1901, and for over a century it held the record as the largest snake known, estimated between 7 and 11 meters depending on which allometry you use. Vasuki, Madtsoiipistorensis, and Gigantophis form a phylogenetic clade, Indian origin, African arrival, connected by the collision that reshaped the continent, though not everyone agrees on the route. Rio and Mannion offered a more conservative reading in 2017, that the distribution is better explained by an early Pangondwanan range with dispersal across the Apulian, not a direct India to Africa land bridge. Two competing hypotheses. Both fit the data. Neither is settled. But regardless of which route they took, the pattern is the same. Madtsoiid giants kept appearing independently during the warmest intervals in Earth's history. Titanoboa in the Paleocene, Vasuki and Gigantophis in the Eocene. Different lineages, different continents, same response to the same condition. Snakes are ectotherms. Their metabolism tracks ambient temperature. The largest ectotherms cluster in the hottest environments. In a greenhouse world, the ceiling goes up. Head and colleagues used Titanoboa's size to work backward and estimate that Paleocene tropical temperatures must have reached 30 to 34 degrees just to make an animal that large viable. Data and Bajpai applied the same logic to estimate roughly 28 degrees for Eocene Kutch. Giant snakes aren't an accident. They're a thermometer. But thermometers can drop. By the late Eocene, the greenhouse was ending. Global temperatures fell. The tropics contracted. And the family that had stretched across Gondwana for tens of millions of years began to disappear. In Africa, gone. In South America, gone. In India, gone. Everywhere the climate tightened, the constrictors with the primitive jaws lost ground to newer, more versatile snakes that were replacing them. Everywhere except Australia. Australia was isolated. It had separated from Antarctica and drifted into biological quarantine, carrying its Gondwanan inheritance with it. And there, cut off from the rest of the world, the Madtsoiids kept going. They evolved new species. They adapted to cooling, drying conditions that would have killed their tropical ancestors. And one of them, Wanambi narcortensis, survived all the way to the Pliocene. Wanambi was not a giant on the scale of Vasuki. 5 to 6 meters, roughly 50 kilograms. A non-venomous ambush constrictor that lived in the natural sun traps beside waterholes, waiting for kangaroos, wallabies, anything that had to come and drink. Its small head restricted prey size, the same fundamental constraint that had shaped its family for 100 million years. It killed by constriction, not venom, and it held on in a landscape that had become something unrecognizable from the swamp forest its ancestors had known. It went extinct within the last 50,000 years. The Noongar people of Western Australia have a figure in their dreamtime called the Wajil, a giant serpent associated with water holes and the shaping of waterways. Fossil locations of the related Wanambi-Berriai in Western Australia reportedly overlapped with Nwanga sacred sites. Some researchers have suggested that the rainbow serpent tradition may carry, somewhere deep in its roots, a memory of real animals. Giant snakes, 5 or 6 meters long, waiting beside water, encountered by the first Australians. That's a hypothesis, not a proven connection, but it is a remarkable one. The Madtsoiidae lasted from the age of dinosaurs to the age of humans. They crossed continents on tectonic plates. They grew to 15 meters in greenhouse swamps and held on at 5 meters in Ice Age scrubland. They never evolved the flexible skull. They never needed to. And the last of them vanished so recently that the people who saw them may have turned them into stories that are still being told today.